In this video, we're asked to take the series -1 to the n over ln of n from 2 to infinity and find a value n so that the partial sum s sub n is within 0.001 of the total sum. So we're going to use the alternating series error estimation theorem, which says that the difference between the sum and the nth partial sum is always less than the first neglected term. So what we need to find is what that first neglected term is. We want that first neglected term to be less than 0.001 because that first neglected term is the upper bound of the error. So we don't have to worry about the alternating series part, but I'm going to rewrite our term as 1 over ln, and I'm going to write it as n plus 1 because I'm looking at the n plus first term because I need to stop 1 before that term. And I want that to be less than 0.001. Now, what I'm going to do is I'm going to take the reciprocal of both sides, because that gives me ln of n plus 1 on the left-hand side, greater than 0.001 on the right. Now, rewriting this as an exponential, that tells me that n plus 1 has to be, 1 over that, which is equal to 1,000. Now rewriting as an exponential, that tells me n plus 1 has to be greater than e to the 1,000. It's a very big number. A lot of calculators won't be able to handle it. So n must be the next integer up from e to the 1,000 minus 1. So whatever that number is, we'd round it up to the nearest integer, and that's going to be the value of n. It's quite a large number. A specific calculator can't handle it, but that's how many terms we would need of this series to get within 0.001 of the actual sum.